So now we are going to talk about a very important topic, that is about a Bosch gas. Then what is Bosch gas? In the blast furnace, the Bosch zone is the heart of heat and gas generation. Situated just above the tuyeres, it's where hot air, coke, coal, hydrogen and moisture interact violently at temperature exceeding 1800 degrees centigrade. The gas generated here drives both reduction and heat transfer upward through the furnace. So this is a really zone of complex. Now coming to why calculate Bosch gas? Why does calculating Bosch gas matter? Because it directly affects our furnace performances. The more accurately we estimate the Bosch gas volume, the better we can control ratio length. Number one. Number two is the adjustment of the body permeability is supposed to be the most important part, because if we do not have an idea about the Bosch gas and permeability remain constant, or it is going to adverse, furnace will be highly pressurized, and in those situations there will be a lot of instability to the process occur, and we can say that a other process upsets can also occur which hampered the furnace performance immensely. Apart from those effect, furnaces other effect maybe in terms of coke rate, loss of production, loss of equipment, etc. also. So this part is very important, and that what we want to mention to ensure safe and efficient operation, execution of the furnace process, along with efficient injectant, that is going to control the fuel rate of the furnace, which impact hugely on our cost of production. It also crucial for top gas heat balance and pressure control too. Now let us look into the gas generation reaction in the boss, because unless until we come to acquaint ourselves with the calculation part, we will not able to understand what sort of what quantity, what quality and quantity is going to get generated in the Bosch. Hence, in the Bosch zone, multiple high temperature reaction produce gases like carbon combust to carbon monoxide, steam react with carbon to form carbon monoxide and hydrogen, and injected hydrogen, let it be a injection of a pure hydrogen, then it also takes part in the Bosch directly. So these reactions are primarily contribute to a large gas volume we observe in the lower part. So all those reactions are being shown here in this slide. Now coming to one of the most important part is generally gas generation from the PCI, because what happened that other setups are remain constant. Furnace running with a adjusted coke rate with a moisture optimization point we achieve, and thereafter we continue the process of blast furnace. So thermal control mostly is being controlled at that point of operation is by PCI. So cold and hot, if condition are to be controlled by just making PCI up and down by 5 kg or 7 kgs, that is the minimum quantum that we can tune to adjust our thermal regime. So let's begin with the coal. If you inject 100 kg PCI per ton of hot metal, assume 75% of fixed carbon that gives, then we can come across that what sort of carbon is available there. So this is getting calculated. When carbon react with oxygen, it produces carbon monoxide. It uses a standard of 1.86 normal meter cube carbon monoxide per kg of carbon. So multiply that out and we will get 139.5 normal meter cube of carbon monoxide gas per ton. So we can see that gas from hydrogen injection, what sort of gas hydrogen is generating from the injection. So now let us look into at hydrogen injection. Now if we inject 10 kg of hydrogen per ton of hot metal, then we convert mass to volume using molar ratio. 1 mole of hydrogen weight about 2. 2.016 gram and occupies around 22.4 liter at SCP. This gives us approximately uh, 111 normal meter cube of hydrogen gas added directly to the Bosch. That exactly I want to show. Now coming to the steam contribution, many times we do also put on a lot of steam when thermal controls are becomes necessary to execute within a very shortest possible time, especially in view of BOF incapability to handle higher silicon as a steel making process. Let us also try to find out that steam contribution in the Bosch gas effect up to what extent. So steam from hot blast contribute uh, also up to great extent. Suppose our blast carries 20 gram of moisture per normal meter cube and the total blast flow is suppose 3000 normal meter cube per minute, then over a day that add up 86,400 kg of S2O. So a huge amount. For 3,600 ton of hot metal, that around 24 kg S2O per ton. So this is a way to exemplify to see that what is the intensity. Then breaking it to down using molar conversion, this produces around 29.9 normal meter cube of hydrogen. So this slide shows that what sort of contribution is there from the steam. And now is the time to see the total Bosch gas volume per ton hot metal. So now we bring it all together. Carbon monoxide from PCI gives 139.5 normal meter cube. Hydrogen from direct injection at 111 normal meter cube. Steam contribute around 30 normal meter cube more. So that brings out total Bosch gas volume to approximately 280 normal meter cube per ton of hot metal, even before even before including nitrogen from air blast. But that is not still considered. But if we considered in the next slide as it is shown, then we can say that when we inject air, nearly 79% of it is nitrogen. So with blast rate around 3000 normal meter cube per minute, this add roughly to 200 to 250 normal meter cube of inert nitrogen per ton of hot metal. It doesn't reduce iron, but it adds pressure and carries sensible heat upward. So let us discuss the final takeaway formula. So here is the formula we can use in our day-to-day calculation. So you can say that Bosch gas volume, that is if getting calculated, unit is normal meter cube per ton hot metal. So 1.86 times the kg of carbon PCI added with hydrogen injection, that is in normal meter cube, plus 1.2 times of the steam that is utilized in terms of kg per ton hot metal. And thus this formula gives us a practical and scientific way to predict Bosch gas generation from our input mix. So it is essential for real-time control and safety planning. It is also essential to better way to diagnose the any upset like pressurizing of the furnace due to differential increase or any hang slip sort of things in the furnace. Thank you.